Hello everyone, welcome to my channel Maths Tutor Roja, and this video is for BSc 3rd SEM students, Physics Honors. Here I am solving C5 paper, Mathematical Physics of 2020. So I have already made two videos, part 1 and part 2. Links will be given in the description box. So please go through them. And this is part 3. This is part 3, right? So before we start, please subscribe the channel if you are new to my channel, and hit the bell icon so that you get notified when new video will be uploaded, and also participate the poll that posted in the community post, and also hit the thumbs up button and share with your friends. So now let's start. So the first we're gonna prove this here, integration -1 to +1. This is the question. Pn of x, this is Legendre polynomial. So another Legendre polynomial Pn of x dx is equal to 0. So we're going to prove this. So in order to prove this, we have taken two Legendre equations for these two Legendre polynomials. Okay, so we have considered the Pn of x is the solution of the first equation, and Pm of x is the solution of the second equation. Here we have considered, right? So this is the Legendre equation. So where the solution is y is equal to Pn of x, and here you see where we have taken that z. You see the solution of this equation number 2, Legendre equation 2. So here we have taken in terms of m. So that's why its solution is z is equal to Pm of x, right? So now what we have done here, we have multiplied z with equation number 1 and y with equation number 2. Then we have subtracted 2 from equation number 1 after this multiplication. So then, and doing so, what we have got this step. Then we have rearranged these terms, right? So here what we have done, so here you see we have added dy by dx, and we have again subtracted dy by dx. Now applying same rule, dy by dx can be written as dz by dx into dy by dz. So similarly, this dy by dx also written as dy by dz into dz by dx, right? So now here you see what we have done. Just let me clean this part. Now this whole thing from here to this part. So this is the result of derivative of this term with respect to x. So if you differentiate this term applying a product rule, then you're gonna get this result again, right? So now you see, now let me write this equation on the new slide also. I'm writing the same equation in the new slide again. So here you see, so this is the result we have got at the end. Then we have multiplied both sides by dx. So this dx on this side and that side on the right hand side as well. So we have got this result. Now if you integrate from -1 to +1, why -1 to +1? Because here you see, to prove we are to prove here this integration from -1 to +1 is equal to 0. So that's why we have integrated from -1 to +1, right? And integrating this, we have got this result, right? I hope you know the integration. Here m and n, these are constants, so taken out of the integral. Then now here you see, if you put here +1, then also it will be 0. If you put here -1, then also this term will be 0. If this term is 0, then this whole term will be 0. Okay, because 0 into anything is always 0. So that's why this term will be 0, right? So hope you have understood. So we have left with this part only, right? So now this implies integration from -1 to +1 yz dx is equal to 0 if you divide both side by this n minus m into n plus m plus 1, on this side also n minus m into n plus m plus 1. So 0 divided by these things will be 0, remains 0, right? And if you divide this left hand side by n minus m into n plus m plus 1, then these two will be cancelled. Only we have left with this part, right? So let me clean this part. Okay, so now you see. So what is y and z? So let me go to the previous slide. Here you can see this is y and this is z, right? Y and z. So let's put these values here. Let's put y here and let's put z here. Okay, then doing so we have got this result. So we have to prove this, right? So that's proved. So hope you have understood this. Now let's move on to next question. Actually it's the same question, but here it is given either prove this one or you need to prove this. Okay, same question. So now let me show you here how to do this. So now you see, we know that y is equal to this zn of alpha x and zn of beta x. These are nothing but Bessel's function, right? So here these two are we have considered these two are respectively the solutions of Bessel's equation number 1 and 2. These are the two equations we have taken. These two are as a solution of 1 and 2 respectively, right? Then what we have done with equation number 1, we have multiplied z by x, and with equation number 2 we have multiplied minus y by x. And doing so, then we have added the results, equation number 1 and 2. After multiplication of these two, we have added to get this step. Then again from here what we can do, let me tell you. So here you can see clearly that from this part we can take this d by dx common, and inside the bracket we're gonna left with this part, right? So then okay, then again multiply both side by dx, here also, and here also, right? And doing so we have got this step, d of this one and this one dx is equal to 0. Now integrate from 0 to 1, because here you see two proof into proof. We need to find the integration 0 to 1 into x, Bessel's function of alpha x, Bessel's function of beta x dx is equal to 0. So hope you know the integration part. So integrating we have got this, because you see when you have dx integration dx, then you get x. So similarly integration this one, so you will get this result, right? So now here you see this alpha beta, these are taken out of the integral as they are constant. Then integration 0 to 1 x y z, we have x y z dx. Now here you see what is y and what is z. So already we have mentioned here y is this and this is the z. So if you put the y and z here, then let's go to the next slide. So here you see before we put the x and y here, y and z here, let me rearrange this. So here what we have done, we have separated these two parts. One is written on the other side of the equal sign, another is written on the other side. So we have written these two parts in two different sides of the equal signs. Okay, this one is written on left side, this one is written on right side. So and this minus is taken common, right? So we have got this alpha square minus beta square becomes beta square minus alpha square. So hope you have understood this these things. these are very simple simplification, so you're gonna understand. Hope you're gonna understand here. So 0 to 1, right? 0 to 1. What happens if you put 0? Then this will be definitely 0, and if you put 1 here, you're gonna get this result. So at x is equal to 1. Now you see, we have already mentioned that y is equal to this, and so derivative of y will be alpha zn dash of alpha x Bessel's function, derivative of first order derivative of Bessel's functions of x, right? Similarly, we have considered z is equal to this one, so dz by dx will be this, right? So now if you put this in this above equation, so you're gonna get this result. So now you see, we are doing at x is equal to 1. At x is equal to 1, if you put x is equal to 1 here, here also, here also, here also. So how we have got this right hand side? Just putting zn dy dx y dz dx that we have obtained here. So using this value in the above equation, we have got this result. So if you put x is equal to 1 here also, here also, here also, then you will get this result, right? At x is equal to 1. Now since alpha and beta are the roots of these equations, right, are the roots of these equations, here you can see. So then, so if you put x is equal to alpha, so this value x is equal to alpha must satisfy this equation, right? Must satisfy this equation. So similarly, if you put beta, x is equal to beta, then it must satisfy this equation. So from here you get zn of alpha and zn of beta is equal to 0. So if you put here 0 and here also 0, then you will get this right hand side will be 0, right? The right hand side will be 0, and the left hand side is this. So we got the left hand side, right? And if you divide both sides by beta square minus alpha square, left hand side and right hand side, 0 divided by beta square minus alpha square, then you will get this result. So this is what we needed to prove. So hope you have understood this. So let me write this result here. 0 to 1 x Bessel's function z of alpha x zm of beta x, sorry, not m, zn beta x is equal to 0. That's what we needed to prove. So hope you have understood. I haven't got enough time to solve all the problems. Remaining problems will be solved in the next video. I will try to complete all the questions, all the problems, and solution in the next video, in the next part. So hope you have understood all these things, and please share with your friends. Help me to create my grow my channel and inspire me to create new contents for you. And if you are new to my channel, please subscribe the channel and hit the thumbs up button as well. Also hit the bell icon so that you get notified when new video will be uploaded, next part will be uploaded. Okay, so see you in the next video. Stay connected. Thank you.